Hi guys, you're welcome back to another section of my tutorials. So in this video, I'll be taking you through review exercise on differentiability or derivatives. In our previous lessons, we've gone through the review exercises on functions and point sets. So please do well to subscribe and visit those videos. Let's get straight to what we have here. So our first problem, find the first derivatives of, so let's take the first function, f of x is equal to x squared minus x minus 2 all over x cubed plus 6. Now, how do you find the first derivative of this? This differentiation, what is popularly commonly known as differentiation. Now, this is a quotient rule, but first of all, sometimes you realize that if this should have been improper fraction, which we could have used long division to simplify, it would have been advisable to do that first, so that you get it in simpler terms before you apply your quotient rule. But here, this is x to the power 2, here is x to the power 3, so we are good to go to use the quotient rule. Our u will be our numerator, x squared minus x minus 2. Our u prime, which is the u over the x, is going to be 2x minus 1. Our v will be x cubed plus 6. Our v prime will be 3x squared, and that will be all. You know, by quotient rule, we have v du minus u dv all over v squared, right? We simply apply that here. What is our v? Our v is x cubed plus 6. Then our du is simply 2x minus 1. This minus our u, which is x squared, which is x squared minus x minus 2, right? Multiplying our dv, which is 3x squared, all over the expression v squared, which is x cubed plus 6 all squared. Let me simplify what I have here. I'm going to have here, I'm having x cubed plus 6. Let me rewrite it here so that I see it clearly. 2x minus 1 minus x squared minus x minus 2, 3x squared, all over x cubed plus 6 all squared. Nicely like this. So here, just expand everything, okay? Just expand everything. So we simply have 2x to the power 4 plus 12x minus x cubed minus 6 minus the expression 3x to the power 4 minus 3x cubed minus 6x squared all over x cubed plus 6 all squared, okay? So here you have 2x to the power 4 plus 12x minus x cubed minus 6 minus 3x to the power 4 plus 3x squared plus 6x squared, right? So let's simplify that. I have 2x to the power 4, 3x to the power 4. I'm going to get negative x to the power 4. I have x cubed here, and I have, do I have x cubed? No, that's all. So I have minus x cubed. Then I have x squared, which is 3x squared, right? This is 3x squared. Then here is negative 6, negative plus 6x squared. This plus 6x squared. I couldn't write it for. So I'll have plus 6x squared here, right? Plus this, and I'm going to get plus 9x squared. Plus 9x squared. Okay, let's take note. I think there is an error here. So here, I was simplifying this. I had negative 3x to the power 4, right? I had plus is 3x cubed instead. Sorry, so let me cancel it. Okay, so it's 3x cubed, right? Then plus 6x squared. So I first considered the x to the power 4, this, and I had negative x to the power 4. I moved to the x cube. I have negative x cube here, then I have 3x cube here. That will be plus 2x cubed. Then I move to the x squared. I have 6x squared, which is plus 6x squared. Then finally, I have 12x plus 12x. Then minus 6. Everything over x cubed plus 6 all squared. And that's all. That's all. You need not to go further. So let's move to the second part. Okay, so for the second part, which is 2, f of x is equal to e to the power x over the expression 1 plus x cubed. The same as before, quotient rule. U equals e to the power x, u prime, the same thing. Our v is equal to 1 plus x cubed. Our v prime is equal to what? 3x squared. V du minus u dv all over v squared, right? My v is what? 1 plus x cubed. My du is e to the power x minus my u dv. My u2 is e to the power x, dv is 3x squared all over the expression 1 plus x cubed all squared, right? So this gives me e to the power x for the numerator. Here I have e to the power x, I have e to the power x. I'll factorize it out, and I have 1 plus x cubed minus 3x squared, right? All over 1 plus x cubed all squared. And I think that is all. Getting this is enough for simplification. You need not to go further. Let's consider the third one, that is this. So the third one, I'm having f of x to be equal to open bracket 1 over x squared plus 1 multiplying tan x. So now let's see. This is a product rule, not a quotient rule. We can make it a quotient rule. We can also make it a product rule. But per the originality, you see that there are two functions worth multiplying. You can choose to multiply and you get tan x over x squared plus 1. And I think that will make it so simple than using product rule. So let's see. So solving this problem, my u is what? Tan x. My u prime is derivative of tan x is x squared x. My v is equal to x squared plus 1. My v prime is equal to 2x. So as usual, v du minus u dv over v squared. And this is going to give me, my v is x squared plus 1. Du is 6 squared x, right? Minus u is tan x. Dv is 2x all over the expression x squared plus 1 all squared. That's it. So once I have this here, let's make green above here. Constant projection. Or let's, you can move down a bit. Okay. So once I have something like this, how do I simplify? How do I simplify this? Okay, so there is nothing in common here. So you can probably leave it this way, or you can also divide and it's going to work out. So I'll have x squared plus 1 multiplying sec x squared x, right? All over x squared plus 1 all squared minus tan x multiplying 2x all over x squared plus 1 all squared. Then I can simply take one of these out and I'll get sec squared x over what? X plus 1 minus tan x multiplying 2x all over x squared plus 1 all squared. And this is enough. If you use the product rule, you surely get this answer, right? Now let's move on to the next aspect. So we are moving on to the second part, finding the implicit derivative. Implicit derivative. Implicit derivative. Okay, so for the implicit derivative, I have the first one to be f of x. Oh, sorry. I have the first one to be y squared minus s squared is equal to sine of the expression xy. Y squared minus s squared is equal to sine of the expression xy. So the problem is saying that find the implicit derivative of the function y or theta with respect to what? X or r. So for this particular problem, our independent and dependent variables are x and y, so we only focus on x and y. So we are finding the y over the x. Okay, so now let's start. We have y squared here. Now take note, whenever we say implicit derivatives, we only mean that we cannot convert our equation here into an explicit form. From differential equation, we have what we call implicit solution and explicit solution. When you say an explicit solution, it's the solution which has y is equal to, meaning y separated from the rest of the variables. But here we cannot separate our y's and x because we are having some transcendental function of xy. You see, you can't take y out. Okay, so here we differentiate all together. Now, what's the derivative of y squared? Is 2y. But whenever you differentiate it, now let me show you something. When we say that differentiate x squared with respect to x, let's say y is equal to x squared with respect to x, this is the same as the y over the x is equal to 2x the x over the x. That is why the x over the x will cancel and it will be left with 1. So take note, whenever you do any differentiation, we have the change in that variable you have changed right now over the one we are changing with respect to. Here, when you change with respect to x, it will be the y over the x. Here, it's the x over the x, making it 1. So that's what you should take note of. Now, let's move on. Well, knowing that, meaning that here, I'm supposed to bring my what? The y over the x, because I changed my y with respect to x. It's just an identity. Minus here is 2x, okay? 2x. When I bring the x over the x, it's of no use. So I just move on. Now, this is a sign. And remember, within the argument of the sign is a product of x and y. That is what you should take note of. Okay, product of x and y. So how do we go about this? How do we go about this? So this is obviously a product rule. And being a product rule, we will take one and what? Leave the other while the other one is acting. So now this is what I'm going to do. I'm going to differentiate this sign with respect to what? X, whilst I maintain y. Whilst I maintain y. So whilst I maintain y, x is what I'm looking out for. Okay, so I'm going to get y will be a constant. It will come out y sine xy. Take note. Plus, now I'm going to maintain x and I will differentiate y. Okay, I'm going to have x sine what? Xy. But here I'll write the y over the x because I change y in this manner. Please take note of what I'm doing. It's very confusing, but if you understand the concept, you wouldn't get it wrong, right? So at this point, I'm going to have 2y dy on the x minus 2x is equal to y sine of xy plus x sine of xy dy over the x, right? So what am I going to do? We only want the y over the x, so we group the y over the x at one side and the other one to the other side. So 2y dy over the x minus x sine xy dy on the x, right? Xy dy is equal to y sine of the expression xy plus 2x. What do? I factorize the y over the x out, and I'm left with 2y minus x sine xy is equal to y sine xy plus 2x. Then I divide through. So the y over the x is simply equal to y sine of xy plus 2x all over the expression 2y minus x sine xy. Okay, that's all. Powerful. Now let's move to the second one. I have my 2 to be x cubed plus y cubed minus 9xy is equal to 0. This is an implicit and it's x and y, okay? Wherever you see x, you differentiate with respect to what x. So this is what 3x squared dx over dx making 1 plus this is 3y squared dy over dx minus when I come here, it's product rule. Remember, it's product rule. So to do this, you consider x at a time and you consider y at a time. Now let's differentiate with respect to x, making y a constant. With respect to x, making y as a constant, I'm going to have negative 9y plus, now let me differentiate with respect to y, making x as a constant. I'm going to get negative 9 x dy over dx. Take note, is equal to 0. So at this point, I'll have 3x squared, right, minus 9y plus 3y squared dy over dx minus 9x dy on the x. As usual, we are looking out for dy over the x, so I'll group that at one side. So I'll probably send this one, I'll carry them to the other side. So I'll have here 3y squared dy on the x minus 9x dy on the x, right, is equal to 9y minus 3x squared. I simply make my dy over the x the subject, and I'll surely get so let me clean what I had here initially. I'll have this to be equal open. So I'll factorize. I'll have 3y squared minus 9x is equal to 9y minus 3x squared. Right. So the y generally on the x is equal to 9y minus 3x squared all over the expression 3y squared minus 9x. That's all. Let's move to the third one. So let me do some cleaning here so that you see it work. So okay, so let's move to the third part. So for the third part, I have x squared y plus y squared x is equal to 6. Is equal to 6. Let's move on. This product rule again. 2x, I'm differentiating with respect to x. 2xy plus x squared dy on the x plus here too I have x. When I differentiate with respect to x, I'll have y squared plus 2xy dy on the x is equal to 0. When I differentiate 6 is 0. I simply group, so x squared dy on the x plus 2xy dy on the x is equal to negative 2xy negative y squared, right? Yeah, this and this. Therefore, dy of dy on the x is simply equal to, well, let me factorize first. So I'm having 2xy, no, plus x squared, okay, plus x squared is the same thing. Negative 2xy minus y squared. Therefore, my y over the x is equal to negative 2xy minus y squared all over 2xy plus x squared. That's all. Now let's move to the fourth one. X plus tan of xy is equal to 0. So we still under the y and x, okay? So if I'm to simplify this expression, I'll simply differentiate x with respect to x, and that is 1. Now this is product rule. Let me differentiate this when x is what? I mean, what I'm differentiating with respect to. So differentiating tan x with respect to x, y becomes a constant. And I have y tan of the expression xy, okay? Plus, now I'm going to differentiate with respect to y. So I'll have x tan of what? Xy. But since I'm differentiating with respect to y, I'll add the y over the x after j equals 0. Therefore, I'm going to have x tan xy dy over the x to be equal to negative 1 minus y tan what? Xy. Therefore, I simply divide through by a coefficient of the y over the x, giving me negative 1 minus y tan xy all over the expression what? X tan xy. That's all. Finally, I'm here. So let's see. Okay, so let's see. Finally, I'm here. So I'm having my fifth one, which is s cos 2x plus 0y is equal to y sine x. Okay, it's equal to y sine x. Y sine x. Now I have should I say a composite function? Yes. I have cos of what? 2x. Sorry. Now I'm having x multiplying this, but take note, x times a composite function. So I'm going to have a product rule between a composite function and this single function here. The reason is this is cos 2x plus 3y. This is x. And even cosine itself is a transcendental function or trigonometric function, whilst x itself is a monomial. So I cannot do anything together. So please kindly watch what I'm doing now. So this is what I'll do. This is a product rule, okay? Let u be equal to what? X, okay? Let v to be equal to what? Cosine 2x plus 3y. My u prime is what? 1. My v prime now is 2 ways. If I want to differentiate this function, remember that we are differentiating both with respect to x and y at the same time. So with respect to x, I'm going to have what? This to be a constant, so it will be 0. With respect to this will be 0, okay? Once this is 0, I'm going to have 2 cosine of the expression 2x plus 3y. Now, this vx, okay? Now vy, that is v prime with respect to y. I'm going to have my 2x to be what? A constant, so it will be 0. So I'll have 3 cos the expression 2x plus 3y. But remember, we add the y over the x. Don't worry. Yeah. Now I have these two. I can go ahead and do what I'm having here, right? So here I'll have, you know that product rule is u prime v plus what? V prime u, right? But now I'm having two separate v prime. I'm having two separate v prime. So meaning I have to do for both of them. Both of them. So let's start. I'll have maintaining x, differentiating this. So I'm going to have x towards vx separately, then x to vy separately. Take note. X to vx separately, x to vy separately. So let's go. Now I'm having x to vx. So x to vx, I'll have x multiplying. Let me clean here so that I get more space. Okay, so I'm having x multiplying. When I differentiate this with respect to x vx, I had what? 2 cosine of the expression 2x plus 3y. Plus, when I differentiate x, I'm getting 1. 1 multiplying the v itself, which is what? Cosine of the expression 2x plus 3y. And that is for only x towards vx. Now, let's go to x to vy. So, it's still plus x. My vy is what? 3 cos x 2x plus 3y dy over dx. Plus, when I differentiate x, I'm getting 1 times what? Cosine of the expression 2x plus 3y. That's all. All this is equal to what I have here. So, let's see. Let me write it boldly here. So, on that, please please pay attention here. So, see, I'm having s 2 cosine of what? 2x plus 3y plus cosine of 2x plus 3y plus x 3 cos 2x plus 3y dy on dx plus cosine of what? 2x plus 3y. And this should be equal to, now let me do this part. So this part is also product rule. When I differentiate with respect to x, maintaining y, I'll have y cos x plus, now I'm going to differentiate with respect to y. I'll have sine x dy over dx. So how do I simplify? I have this in the same terms. So I'll add, right? When I add this onto, I'll simplify. So simply watch closely. Here is 2x, cosine of the expression 2x plus 3y. This will give me plus 2 cosine of expression 2x plus 3y, because this and this will combine. Here I'll have 3x cosine of 2x plus 3y. All is equal to y cos x plus sine x dy on dx. Now this and this will add to be 5x cosine of 2x plus 3y plus, here will be 2 cosine of 2x plus 3y is equal to what I have still, plus sine x dy over dx. Now remember that I can factorize my cosine, so cosine 2x plus 3y multiplying the expression 5x plus 2 should be equal to y cos x plus sine x dy over dx, right? So this is quite longer. So once I have this here, what do I do? The next thing is to make, the next thing is to what? Make dy over dx the surface, but I have to subtract this. So I'm having cosine of 2x plus 3y, which is multiplying 5x plus 2 minus y cos x, then it's equal to sine x dy over dx. Then to find dy over dx, I simply divide through by what? Sine x, and I'm done. Sine x. So this cancel this and I'm having this. That's all. So this is quite a lengthy one, so watch closely. Let's quickly move to the next one, which is this. Okay, so now let me move to the last one, which is cos r, the sixth one. Cos r plus cos theta is equal to r. So in the question it says with either what is theta towards r. So now theta is what? Our dependent and r is our independent. So simply this becomes what? Negative sine what? R plus here is what? When you differentiate what, you get negative cosec squared what? Theta, right? Theta. D theta over the r. Now the r, when I differentiate the r, I get 1. So simply I want this. Okay, so I'll send that one there. Or I'll send even it there. So I'm going to have negative sine r minus 1 is equal to cosec squared d theta, so cosec x theta d theta, theta d theta over d theta r. So d theta over d r is equal to negative sine r minus 1 all over cosec squared theta. That's all. This is all for the implicit derivatives. So on that note, let's come to this new set of problems, which we see find the general formula for the nth derivative, nth derivatives, nth derivatives, and how do we go about such problems. So let me get a new page for it. So okay, so see, we are starting with the n derivative of like x, natural log of x, n derivative of the natural log of x, n derivative of the natural log of x. So let's see how we do that. When you say n derivative, you mean that when you take the higher derivative, so first one, y is equal to natural log of x, meaning nth means that first, second, third, fourth, fifth derivative, it follows a trend, then you just find the general formula for that. So let's take the first derivative, which is y prime. Y prime is what? When you take y prime, then x, you all know that natural log of x, you are going to get what? The derivative of x over itself, so 1 over x. Now let's go to the second, y prime prime. Y prime prime will give us what? Now we are having this, right? This is our y prime, so this is what you are differentiating. So what are you going to get? You are going to get what? Negative 1 over x squared. This is because this is the same as x upon negative 1. When you multiply, you get negative 1 minus 2. So that is why. These are some basic things you should know of it, okay? So once I have this, I'll go to y prime prime. That is the third derivative. Here I'm having the same as x to the power negative what? Um, negative x to the power negative 2. So when I'm doing this, I'll have positive 2 x to the power negative 3, and it's the same as what? 2 over x cubed. So this is the third derivative, right? Now let's move to the fourth derivative. Fourth derivative is going to give me, as I had here, I'll have negative 6 x to the power negative 4, which is the same as next 6 over x to the power 4. Then let's go to the fifth derivative. So fifth derivative, I'm having negative. So here will be positive 24, right? X to the power negative 5. The same as 24 over what? X to the power 5. So let's see the trend. I have 1, 2, I have 3, I have 4, then I have 5. It should be enough for me to get a trend. We realize that always it's either positive or negative, positive or negative. When it was n is 1, our first derivative, it was positive. When n became 2, it became negative, 3 positive. So meaning odd numbers attain what? Positive, whilst even numbers get negative, right? Then I can make my generalization that the n over the x n, the ny over the xn of len x is generally going to be, so I'll have open brackets negative 1 to the power what? N minus 1. Take note, negative 1 to the power n minus 1. When I put 0 here, for my 1, I'll have 1 minus 1, I'll have 0. Well, 1 minus 1 will be 0, so that it will be 1. That is why I have positive. For 2, I'll put 2 here. 2 minus 1 is 1. Negative 1 to the power 1 will be negative. So that is why it's negative 1 to the power n minus 1. All will be taking positive, even will be taking negative. Now I move on to the other aspect. So this multiplying n minus 1 factorial, n minus 1 factorial. So this is giving us the numerator. When I take here, when I take this side, when I take n minus 1 factorial, 1 minus 1 is what? 0, and 0 factorial is 1, obviously. When I come to this side, it's still the same, but for the 2, okay, for the 2, let me write it in full so that you see. So all this expression here all over x to the power n. So this is actually the general formula, but let's see how valid it is. Let's see how valid it is. Please take note, the n that we are dealing with is the nth power. This is our first derivative, second, third. So let's see the third derivative. The third derivative, n is 3, right? When I put 3 here, 3 minus 2 is what? 3 minus 1 is 2. What is 2 factorial? 2 factorial is what? 2. And that is the 2 we have here. When I take for my fourth derivative, realize that n is 4. 4 minus 3 is what? 4 minus 1 is 3. 3 factorial is what? It's 6. And that is what I have here. It's the same thing. All over x to the power 4. So we realize that when we move to even the 20th term, x to be to the power 20. First term we had to the power 1, second to the power 2, third in that order. So this is simply the n derivative following x. Let's go to e to the power x, number 2. For e to the power x is so interesting. E to the power ax. Our first derivative y prime will be equal to what? A e to the power what? X. Is that not it? You just take the coefficient. Our second prime will be what? Here I forgot. It will be a squared e to the power what? Ax. Our y prime will be equal to what? A cubed e to the power ax. What is it telling you? So generally, the n y over the x to the power n is simply equal to what? A to the power n, that is first derivative it was 1. First derivative was 1, second it was 2, third 3. Multiplying e to the power ax. As simple as that. As simple as that. Let's see finally our third one, which is what? Sine. So number 3 is what? Y is equal to sine x. Sine x is also interesting. Now let's see something. First derivative will be what? Cos x. Second will be what? Negative sine x. Third will be equal to what? Positive negative cos x. Then fourth will be what? Sine x back again. So it will tell, it will be going like that. It will be a cycle. So you started with sine x. After the fourth derivative, you are going to come back to what? The same level you were. So for that reason, for sine, we generalize it like if your n is let's say 4k. The reason is we are using a 4 cycle. you know, after 4 times, you come back to what, sine x again. So we are saying that if your n is what, in the form 4k, that is should I say 4, which is a multiple of 4, then you are going to have what, sine x. So meaning that if you want y to the power 16, you usually have what, sine x. It's a multiple of 4. Then if your n is in the form 4k plus 1, you are going to get what, cos x. You realize it here, cos x, cos x. And if your n is what, 4k plus 2, you get negative sine x. Then if your n is equal to 4k plus 3, you get negative cos x. This has been a very long video. Thank you for being with me throughout, and please don't forget to like, subscribe, then you share.